Okay, so lesson 25, as I mentioned, is derivatives. You'll notice it says the constant multiple rule for derivatives, the derivatives of sums and differences, and proof of the derivative of a sum, which there's some information on the back. We're not actually going to do anything with it, but we'll look at it a little bit. Now, good news is the derivatives we're looking at, these are very much building on what you already know. Okay, so it's just really, honestly, there's a, if I had to, I could easily skip this or combine it with another lesson because I hesitate to use the word it's common sense, but it just makes sense with what we just learned. Okay, so the constant multiple rule basically says if you have the derivative of some function and there is a number out front, that number basically just carries through and multiplies by whatever the derivative is. Okay, so like last week when we did, it's like, okay, how do you deal with, okay, if we did the derivative of x to the fourth, how do we deal with that if there's already a number out front? That's what we're talking about today. So if it was 3x to the fourth, how do we deal with taking that derivative now? So, as we look at this, let's look at example 1. It'll make most sense if I just teach it. Let f of x equals 20x to the 15th. And it asks us to find f prime of x. Now, if I show you a little bit of notation along the way, just so you're familiar with it, basically based on what it's saying up here is, okay, we're being asked to do the derivative of a constant, which our constant in this case is 20, times f, or x to the 15th. So, basically what I'm asking you to do here is you're going to keep the 20, and you're going to multiply it by the derivative of x to the 15th. Now, again, the reason I'm doing this is just to introduce some notation. That d dx says to do the derivative of what follows with respect to x. That's saying the derivative with respect to x. So, now the short of it is that 20 out front is going to stay 20. What is the derivative of x to the 15th? Does that sound familiar? Remember your rule from, it's been from what, last Friday? Move that 15 out front. And then instead of 15, it's going to be 15 minus 1, which, yes, is x to the 14th. Now, we have a 15 out front and a 20 out front. What can we do with the 20 and the 15? Multiply. And 20 times 15 is 300. So we have 300x to the 14th. It's possible.
But that makes sense though, because even if you just do the original, you multiply at 20 by 15 and just put x.
Yeah. When I very first taught this lesson, like my first time ever, I threw in one with a constant in front because to me it just seems like we could have very easily learned it the first day, but they break it down more. But yeah, so I mean, the short of it is, I'm not expecting you to necessarily write it out like this. I mean, you can just give me an answer because it's, you take the 15 out front, so 15 times 20 is a 300, subtract 1, 14. I mean, that's a stretch for me to write out work there on that one. Okay? Okay, example 2. Find f prime of x and g prime of x given a is f of x and b is g of x. So, f of x is 3x to the square root of 2. Gotta make it fun here. Different? Creative? I don't know. So, not fun, huh? Okay, f prime of x. Thoughts on what we're doing here?
So if we take the square root of 2, multiply it by 3.
The 3 is going to stay. Then we're going to bring that square root of 2 out front. So it's 3 times the square root of 2. multiplied by x to the square root of 2 minus 1. Okay, well, that's, okay, so the questions are, can I subtract square root of 2 minus 1? No, not unless we're going decimals, right? Which we're just going to leave it at square root of 2 minus 1. Can I multiply 3 and square root of 2? Not really. About the only thing I can do is I can write it without the multiplication done. Okay, in other words, like, you know, officially I could write 3 square root of 2 x to the square root of 2 minus 1. That is about as an official as I can get there. Which really isn't that much different from the line above it. Okay, B. G of x is negative 14, x to the negative 15th. Okay, so for today, I'm still going to write out separate, but we have a negative 14 out front that you are going to multiply by. Bring that power out front as negative 15. And then x to the negative 16, because negative 15 minus 1 is negative 16. Ways to clean that up. Well, negative 14 times negative 15 is 210. So you could possibly write your answer as 210 x to the negative 16. Or since there's a negative exponent, move it to the bottom, becomes x to the positive 16. 210 has no negative exponent, so it stays on top. Those answers are equivalent, right? They're equivalent. They're both acceptable depending on the circumstance. Is that a decent answer for you? And again, it's one of those things, multiple choice. If you're provided this in multiple choice, recognize, you know, they're both there. Okay. Not horrible to have a constant number out front, is it? Okay. Example B, we're looking at example 3, 4, and 5 here. This section of the lesson is derivatives of sums and differences. So if you have multiple terms added or subtracted, similar to what we just saw. If we, you know, had A and B from above added, you know, how would you do the derivative? And basically, this fancy notation is saying the derivative with respect to x of f of x, either adding or subtracting g of x, says that you're going to do the derivative of f of x, you're going to add or subtract the derivative of g of x. So basically, it's just saying if you have individual terms, you take the derivative of each individual term that's added or subtracted. Okay, nothing fancy here. So if you look at example 3, first of all, notice it's dy dx. So that's a derivative of the y equation with respect to x. Is what we're being asked to find. Y is given as 4x to the negative third minus 2x square root of 2 plus 4. Okay, what are we going to do? Okay, one by one. So derivative of 4x to the negative third. You guys okay with that? Negative 12x to the negative 4. Because negative 3 times 4 is negative 12. Negative 3 minus 1 is negative 4. Okay? Then we have a term being subtracted, right? So now we're going to do the derivative of that. What does that become? Yep. Now, the only thing I didn't catch there is the sign. If there's nothing else changing it, that minus sign just carries down, right? So there's already a 2 times it by the power. So 2 square root of 2. X, subtract 1 from the power, and square root of 2 minus 1 is just that. And then plus 4. What? No. No.
Or is it like an imaginary 1 out?
Well, let me ask this question.
So there's just 0.
Yeah. What is x to what powers beside that 4? Invisible, that is when you have a constant, there's an invisible x to the 0. Okay. Yeah. Okay, so when you have a constant, we don't say there's an invisible x to the first because that would be visible, right? There's an invisible x to the 0. And so what's going to happen when I take the derivative of 4x to the 0? You're going to take that power of 0 down, right? And multiply, and 0 times anything is just going to make it 0. The lesson to get from this: the derivative of a constant number is always 0. So you don't have to write that plus 0 in. You don't have to write in x is 0 up on the problem. Just learn to understand the derivative of a constant is always 0. Okay, so if I clean this up a little bit, there's not really a whole lot of cleanup I could do. I mean, negative 12x to the negative 4th, you can leave it like that, or you can write it as negative 12 over x to the 4th, minus 2 square root of 2, x to the square root of 2 minus 1. That can't really clean up. The one part I will clean up is I will not write the plus 0. Okay, moving along. Find f prime of x, where f of x is the given following. What would be helpful to do before we start taking the derivative of f of x? Yeah. Yeah. The only derivative we know, the only derivative rule we know is how to take the derivative of x to some power. We don't have any other derivative rules right now. And, I mean, for something like 3 over x to the 4th, that's the rule we'll always use. And so I'm just going to rewrite this. F of x. So 3 over x to the 4th is equivalent to 3x to the negative 4th. That is a minus 2x to the pi. Yeah, we're not going to throw a variable in the exponent. That's a ways down the road. Okay. And then we have a plus 2. If it's x to negative 2 in the denominator, that's really x to the positive 2 in the numerator. And plus 4. Does that help you some? Now, I'm not saying you have to necessarily rewrite that out with every problem you do. Obviously, you know, this is notes. This is where we're learning how to see it. You will probably hit a point where you don't necessarily rewrite that out. I don't know. Okay. F prime of x. Derivative of 3x to the negative 4th. Negative 12, x to the negative 5th. Minus derivative of 2x to the pi.
2 pi x to the pi.
Good. 2 pi x to the pi minus 1. Derivative of 2x squared. 4x. 4x is the first, but 4x is fine. Derivative of 4. 0. So there's my answer. And are you going to necessarily have these square roots and these pies and stuff in your powers? This is kind of a teaching experience. You're not, when you're just generally doing derivatives, that's normally numbers in your powers. Okay, example 6. Let s equal negative 16t squared plus 42t. What it should say after that is find ds dt. Okay. Now, why is it ds dt instead of dy dx? Because these are the variables used, right? The top variable is what it, s equals, so it's ds. The derivative of s with respect to the variable in the problem is t. So, ds dt, here we go. Derivative of negative 16t squared. Negative 32t. Derivative of 42t. Can we agree with that? What's the invisible power on 42t? 1. So you'd end up with 42 times 1, which is 42, t to the 0, which is 1, and we just don't usually write. So it's just 42. So the basics off of that rule is anytime you have the derivative of a variable raised to the power of 1, the short of it is you just drop the variable off and you have a constant. Obviously, the power rule reinforces that, how do you deal with the derivative of a power, but okay. Questions? Oh, I did forget I do have something to talk about on the back. We're not really actually doing anything on the back, which is why I think I kind of pushed it out of my head. Okay, so it's already written out for you, but just, it's proof of the derivative of sum. So the idea is the derivative of a sum, so the derivative of f plus g is equivalent to the derivative of f plus the derivative of g. Okay, and that's the proof here. Now notice, what was used to do this proof? Definition of derivative. Okay, that's what we used to do this proof. The idea of the limit, because if you're trying to take the derivative of f plus g, so derivative of f of x plus h plus g of x plus h minus f plus g all over h. Going through and doing some cleanup. So here it's subtracting these two, so distributing that subtraction sign. Over here it's reorganizing. F's out front, G's out back. In the next row it's separating that into two fractions. F of x plus h minus f of x over h, and separating those two fractions into two limits. And notice this limit represents the derivative of f of x. This limit represents the derivative of g of x. So it's just taking the definition of derivative that's ugly and manipulating it around. Okay, so that's just the proof showing us that, yes, we can do that. Not that you need the proof, because most of you guys would have said, okay, yeah, sure, I'll do that. But that's the way I am now. So, okay, questions?